we've just said that Kotlin is an object-oriented language with first-class support for functions. But first and foremost, it is object-oriented. And as such, we have classes, we have objects, we have instances of classes, which are objects, and we have first-class objects, which we'll also see. But to declare a class in Kotlin, it's as simple as just writing class and then the name of the class. That's it. I don't need any open braces, close braces, or anything like that. It's just class and then the name of the class. Now, like any other language, Kotlin can also have properties. So a class can have actual properties. If I want properties, I do have to open the curly braces, and I can do, for instance, var id equals 0. Now what this is actually declaring a property, and you can see that it uses basically the same syntax as we've used for declaring variables. So just the name of the property, and I'm initializing it. I don't even have to be explicit about the type. If I want to be explicit, I can be. I can just say string and initialize the value. Now, one thing to notice different from Kotlin than other languages is that Kotlin doesn't have the concept of fields. So you can only declare properties. There are backing fields or auto fields that we'll see how to access, but by and large, there's no such concept as a field in Kotlin. So anything you declare here is a property. And much like variables, we can have immutable properties. So for instance, I can have a surname that is immutable and initialized to empty string. Of course, this doesn't really make much sense in this case because now I would have a customer class with a property initialized to a value that I can never change, which I would want to, and we'll see how to do that in a moment. To create instances of classes, I can just declare a variable, customer, and then write the name of the class. Notice one thing missing. There is no new keyword in Kotlin. I can just create the instance by referencing the name of the class. To access the properties, I just do id equals 10 and customer name equals Hadi. So that's very straightforward dot notation to access, and then we can do whatever we want with that customer. Now, here what I'm doing is I'm basically creating a customer class and with two properties. But the thing is that I'm initializing these properties. What happens if I remove this initialization? Let's make that int and remove this. You see that the compiler is complaining and it says, oh, you haven't initialized this property. One can actually create an initializer, right? And with that, what that will do is obviously initialize it. But what we want to do is actually move these to constructor parameters, because I don't need to initialize these constructors when these values need to come from the time when someone creates the class, right? I don't know what ID would be from beforehand or a name would be from beforehand. So basically what we're meaning it here is that we want to pass in the values when we're creating the class. And we can do this using a very, very simple syntax in Kotlin, which is basically saying, okay, well, a traditional way of doing it would be like, okay, I'm going to have an ID of type integer, and then I'm going to have a name of type string, okay? And then here is, let's give it different names, init ID, and then init name. And then I want to initialize this with init ID and this with init name. Okay. Now, this is kind of like cumbersome because we're passing two values to the constructor and then we're setting the property values. And I can say, right now this is name Hadi, and that works, but it's cumbersome, right? Because I'm repeating a lot of code. Why can't I just kind of basically declare this property and initialize it in one go as values being passed to the constructor? Well, we actually can do that. I can remove these declarations here and just declare them directly on the single line of the constructor. So here I say var init, var and name. What I am doing now is basically using another syntax to say that this customer class has two properties, the ID and the name as before. but I'm also passing these as values to the constructor. So effectively, anything between these two brackets becomes the constructor for the class. Before, it didn't have any constructor, it just had, well, it had a constructor, but it didn't have any arguments passed in, and now it has two arguments. But these two arguments are also properties. So effectively, this var in front is declaring a read-write property for this class. If I remove this var, then it is no longer a property. It's just a value being passed into the constructor. So you can see here that customer name exists, but customer ID does not, because it's not a property. It's not declared as a property. As soon as I add a var or a val, it now becomes a property. And this is exactly what I wanted to accomplish. The ability to initialize values directly when I call the constructor. Now, for many scenarios where we're actually passing in values as part of the constructor because we want to determine those values when the object is created, this is perfect. In fact, we can even remove the body block and we can just have a property declared as part of the constructor and access those. Sometimes we want to do a little bit more sophisticated things in part of the initialization block. How can we do that? Well, if we want to just provide a default value, we don't need the initialization or any constructor block or anything like that. We can just say default value there. So now we can have constructors that take multiple arguments. Some of these can be default, just like functions. So I can create a second customer here, and this customer takes only one value, which is 10. Okay? What if I want to go further? What if, for example, I want to do something strange like convert the name to uppercase? What we can do is create what's called the init block, which is basically the initialization block for a class, and basically it's executed when an instance of that class is created. And we do this by creating an init, by declaring init and then a block, and here I can do pretty much anything. So I can say, for instance, name to uppercase. And what that's going to do is convert the name to uppercase. So let's go ahead and execute this, and let's say print line customer name, and let's see what happens. Now you notice here that nothing has happened because it's actually created an uppercase, but it's not assigned it to any value. So if I want to actually assign that to the property itself, I would have to do name equals uppercase, so assign the value, because otherwise it's just executing it. It's not returning the value. So we can now see that now it does convert it to uppercase. We've seen that we can create constructors and we can pass default parameters to default arguments to the constructors, meaning that effectively we have multiple constructors, so to speak. We have, in this case, we can see in the code we have a customer with 2 parameters, and then we have customer constructor with 1 parameter. But we also have the ability to create actually secondary constructors in scenarios where it's required. We do this by using the keyword constructor, and then we pass in again any arguments that is required. So I could say, for instance, another string that is passed in. Now it is important for this secondary constructor to always call the base constructor. So here, obviously, I'm calling this with some random values. I'll say, for example, I'll call this with a 0 and empty string. And then inside this secondary constructor, I can then put any kind of code that I want. So this block here would be equivalent to what would be the init block on our primary constructor. So when required, you can have the ability to create secondary constructors in addition to having the primary constructor with default arguments. Now let's get back to properties. And we've seen that when we created this var and ID that we've actually declared it on the constructor line, this has basically kind of like this in the case of the name, it's just a read-write property. In the case of the val, it's an read-only property. But what if we want to have like custom getters and setters, which basically means I want to have a way to read the property and do certain things and then I want to have a way to write the property and do certain things, and not just the default reading and writing the values. Well, Kotlin provides us the ability to do default getters and setters as we've seen, and then we can have our own custom getters and setters. And in order to do this, let's, for example, create a property which is age. So let's get rid of this constructor here, and let's get rid of this init block because we want to clean some code up here. And we'll remove this second customer and leave that there. Okay, so now I want to create a property which is of type age. Okay, so we'll say val age, and this is of type integer. And I want the age obviously to be calculated by a date of birth minus the current year minus the date of birth. So I'm going to do a get, and here I'm going to say I want the calendar. An instance, this is how we work with time in Java, very, very complex, so to speak. And we'll say calendar year, and now minus year of birth. Now this doesn't exist, so I'll just alt enter and I'll say I want a create a property year of birth as constructor parameter. And there we go, and it will create it for us. So now we have year of birth passed in here. Okay. Now this is, that should actually be of type integer. So now we've basically created a custom getter for a read-only property. Okay. And since it's a single, it's an expression that could be on a single line, I don't need the init block. If I actually needed the init block, I could just use wrap this in curly braces, and then, you know, if I have multiple statements. In this case, I have a single statement, so I can just use the equals. So now we can see that the customer is requiring a third parameter, and we're going to pass in the year of birth. And if we do an age and run this, it should say that I'm way too old for my age. There you go. So I'm 43. Oh, time flies. Anyway, so now we can, just like we have a custom getter, we also can have a custom setter. So let's say that I want to create a social security number. So social security number, and this is of type string, and it's going to be an empty value. And what I want to do is I want to do certain kind of like business logic, so to speak, when someone sets the social security number, and this is kind of complex, so it's going to be multi-line. So I can say set and value is the actual value that is being passed in. So when someone sets the social security number, it appears in this value. So I'm writing my custom setter here, and I can say if value, for instance, starts with SN, then it's all, sorry, if it doesn't start with SN, then it'll say, well, it's a legal argument exception that, you know, a social security number should start with SN. Social security should start with SN. So what this is doing is basically creating a writable property, a mutable property that's saying that I can set at any time, and if the value doesn't start with SN, then it's going to explode on me. So here, if I do customer social security number equals 1234, and I run this, I should get a runtime exception. There we go. And if I put SN and run this, then it should be all good. And I can actually print out the value. So I could say social security number and print it out. Now, notice how it has not printed it out. And you'd say, why? Well, because I have created a setter for it, but where have I actually set it? So where have I actually set the value? I haven't. I've just checked the value. Now, in order to set the value, remember that we mentioned that in Kotlin there are no fields, but there is a backing field for every property. And in order to reference that backing field, since I've created a custom setter, Kotlin isn't auto-setting that value. For us to set it, though, we can do so by referencing it with the name field. So field is that special field in Kotlin that has the actual value, that holds the value of the property. And in this case, I'm seeing if the value is starts with SN, then it doesn't enter this exception block, and I can actually set the value, so I'll say set the value. And if we run this now, we can see that it should print out the value. Now, notice that this value here, I could have called it, I don't know, Joe, and it's fine. So this can actually be named anything. The field is what's important. If I name this field 1, that's not going to work. Field is a special recognized value in Kotlin, and it's referring to that backing field. So we can see here that we can create custom getters, we can create custom setters. We don't need to have custom getters and setters in each time. We can actually have in certain situations a custom getter, certain other situations a custom setter.